Okay? It's called differentiability. Yeah, there's a mouthful. All right, differentiability simply means that you can take the derivative. So there's some things that that we talk about through this entire year, and the first kind of word that's kind of a calculus word that we use a lot is we talk about something being continuous. And if something's continuous, well, that means it's connected. And things that are continuous are nicer than things that are not continuous. Well, there's another word. And this means it's even nicer than continuous, all right? It's called differentiability, and it simply means you can take the derivative, or more importantly, you can draw a tangent line, right? Because to take the derivative is to find the slope of the tangent line, meaning you can draw a tangent line. And so I'm going to just put some pictures on the board, and we're going to talk about why, where I'm going to put this is something that is differentiable, and then I'm going to draw some things that are not differentiable, right? So if I say this is an example of a function that is differentiable, meaning every spot has a tangent line, right? You can look at it and say, oh, there's a tangent line, tangent line, tangent line, tangent line, tangent line. So this is differentiable everywhere, right? Translation, really, really nice, right? There's going to be some things that we talk about where I say something's differentiable, and you say, okay, that means things are nice, nothing weird's happening, all right? Here's an example of something that's not differentiable everywhere. Right? Clearly here, because the function doesn't even exist, you can't draw a tangent line. All right? All right? So that's kind of obvious, right? Here's another place. Here. It's not differentiable here. Right? You've got a break, right? Anytime you have a break, there's no chance to take a derivative, right? These are the obvious ones, right? Okay. The next one. This isn't differentiable, right? And this is the explanation my calculus teacher gave me in high school, and that's what I kind of use forever. For something to be differentiable, you have to be able to draw like a unique tangent line. And a tangent line is something that crosses at one point. And if you look at this, notice you can draw this line that crosses at one point, this line that crosses at one point. You see you could draw lots of lines, and since you can't draw just one line that crosses, it's not differentiable, right? This has got a special name. It's called a cusp, and believe it or not, that's a pretty easy function to. We're going to graph this. Like you may not have seen something that looks like this. You will in the next month or so. So this is not differentiable. Like these are obvious. Like if it's not continuous, it's obviously not differentiable. It's like there's a big break. But places where it does a little cusp, right, of something that looks like this, if you get a corner, right? In my mind, the cusp and the corner are kind of the same thing, but different textbooks, they'll call this a cusp and they'll call this a corner. And the subtle one is this. Very subtle. Here's the subtle one. Turns out here is not differentiable, and here's why. Derivative means you have to be able to tell me the slope, right? Derivative is the slope of the tangent line, so you have to be able to tell me the slope of the tangent line. Well, it turns out the tangent line of this guy is vertical, right? And what did your Algebra 1 teacher tell you about vertical lines and their slope? They either told you one of two things. In Algebra 1, they probably said no slope. In Algebra 2, they probably said infinite slope. But in either case, derivative doesn't exist here. So these are cases where the function is continuous but not differentiable, right? All right, so that's picture-wise. All right, how does this translate? Like, how can I ask questions? Like, how does the AP exam ask questions? Well, they ask questions. Sometimes it's a picture, right? But more often than not, it looks kind of like this. They give you a piecewise function. So I'll say f of x is equal to they give you a piecewise function. Right? I got two pieces, and they want to know, is this differentiable, right? So, I mean, piecewise functions, we've got, like, here's our piece to the left, here's our piece to the right, and clearly the derivative is going to exist everything less than 2, and the derivative is going to exist everything greater than 2, right? But our question is, does the derivative exist at 2, right? Right? Now, so what do? Well, the first, for something to be differentiable, you have to guarantee it's continuous. Do the two pieces meet up? Right? Do the two pieces meet up? How do you know that? Well, that was something we talked about on the last test, right? Is it continuous? You know, at x equals 2. Let's see, that's going to give me a 5. At x equals 2. Oh, look, that equals 5. So right now, I know the two pieces meet up, right? Like, I got a parabola on the left, I got a line on the right. I know they meet up, yay, right? And if I were to graph it, okay, so let's see. We're up 1. Our parabola is doing this. We're down 3. 1, 2, 3. And our a slope of 4. So this is doing this part. So there's our line. I know they meet up. And how do I know if the derivative exists, right? Well, how do I know if the derivative exists? First, I need to make sure that the two pieces meet, like they don't meet at a corner, right? Got it, all right? Because if they meet at a corner, that's kind of like that, like I had a corner before. I can't make sure there's any bend in it. And this one's actually kind of special. So how do you know that they meet smooth? Like if you were walking on this, there's no bump at all, right? How do you know? Well, here's how you know. You take the derivative. You want to take the derivative. Well, the derivative of this guy, we know how to do this pretty easily now. The derivative of the first guy is 2x. The derivative of the bottom guy is 4. And this is x is less than 2, and this is x is greater than 2. And you ask, what's my derivative at 2? So if I plug 2 into the derivative, we get 4. And this is always 4. Do the derivatives match up at 2? Yes. All right? So what we have is, we have a case where the two dots meet. We also have a case where the derivatives match up, meaning this is completely smooth. You get this nice little parabola, and then it does a perfect transition to a straight line. There's no bump at all. Does that make sense? Yes. Okay. So as far as differentiability goes, you got pictures is pretty obvious. If ever it breaks, it's not differentiable. If you've got corners, it's not differentiable. Okay? The tricky one is the vertical tangent line, and it always has that little swoopy thing. It's not differentiable. So identifying a picture isn't so bad. How do you identify, if a function's differentiable? When it's piecewise functions, two things have to match up. The first thing that has to match up is you have to make sure it's continuous. And the second thing you have to do, once you establish the two dots meet, then you have to establish, do the derivatives match up at that point? Because if this derivative was 3 and this was 4, then that would, even though they connected, they would have created a corner because they would have different slopes. Is that all right? Okay, so that was one thing I needed to talk about. I don't know why I didn't talk about it when I first did taking derivatives. I'm going to blame wearing the mask. Okay? But that's differentiability. And there are going to be a lot of things that I talk about from this point forward where I say it's differentiable. And if I say it's differentiable, your translation is that means really, really nice, right? that means the function doesn't do anything weird, right? Right? Differentiable is way nicer than continuous. All right, now we need to pick up from, kind of finish what I started talking about Friday. So how do you take how do you get questions on the AP exam? Well, first I want everybody to write this chart down. We're going to write x, f of x, g of x, f prime of x, and g prime of x. And this is very, very typical. So I give everybody a little shot to give you a few seconds to write. Okay. So you got your chart, and they define h of x is equal to f of x times g of x. Okay, what do you do? Well, okay, so if h of x is defined as this, and I say, well, what's h prime of x? Like, what happens when you take the derivative? Well, when you take the derivative, right, we have to remember we're multiplying two things together, right? We have our product rule. And so with my product rule, it's derivative of this guy times this plus derivative of this guy times this. Right? That's our product rule. So I'm going to say f prime times g of x plus g prime times f of x. It's just like, if you don't know product rule, you're not going to get this. Right? Because product rule is all about when you have two functions multiplied together. Yeah, you've got to follow this. And then they'll say, what is h prime of 4? Because the only x value they gave was 4. So if I ask what h prime of 4 is, well, let's see. I've got to look up, what's f prime of 4? That's 0. What's g of 4? That's negative 2. What's g prime of 4? That's 8. And then what's f of 4? That's negative 4. Do you see how that chart works? Do you see how a calculator would give you basically zero help at all? Because I know there are calculators that there's tons of stuff online. Actually, your calculator takes derivatives pretty nicely. I've got some calculators that do all the symbolic manipulations. There are several calculators. Like, I have a handheld calculator. You can type in, what's x squared minus 6x minus 3 equals 0 and solve. And it'll give you answers in terms of i's and square roots, like they get plugged in the quadratic formula. You can type in, actually, a lot of you can do this now. You can ask Siri to take the derivative, and Siri will take the derivative for you. You can say, hey Siri, what's the derivative of x squared? And it'll pop up, oh, it's 2x. Hey Siri, what's the derivative of secant x? Oh, it'll tell you. All right. It'd kind of be funny if someone was listening and their phone actually solved that because I told Siri to do something. But I don't know if that'll happen or not. Anyway, so we get, oh, that's what I'm going to do in 6th period. I'm going to have everybody with an iPhone put it next to the speaker, and I'll see if I can get everybody's iPhone in 6th period to do that. I'm very childish. Okay, now, and so this gives me negative 32. All right, your turn. Right? So if I define h of x to equal this, you plug it in and you've got it, right? All right? So I would like you guys to compute, what if I defined h of x to equal f of x over g of x? And I want everybody to compute h prime of 4. Oh, I gotta turn this on. So, let's see, when I plug this in, so let's see, h prime of x is going to equal derivative of the top bottom minus derivative of the bottom times the top all over the bottom squared. Now we just start plugging in. F prime of 0, well, that's 0 times, doesn't really matter, minus, whoops, move down. So I can say h prime of 4 is going to equal 0 times negative 2 minus, what's g prime? That's going to give us 8 times f, which is negative 4, all over g of 4 squared, which is negative 2 squared. So I end up with 32 over 4, which gives me 8. Did I do that right? Okay, good. That's important. Okay. So I kind of like questions like this because, like, all it does, do you understand what quotient rule? How do you do quotient rule, right? The computation isn't ugly. The calculator does not help you at all, right? You have to know how to plug stuff in. The other way is, I may have to, whoops. The other way I can do this, oh yeah. This is actually your homework. One of the homework problems. You've got the odd one, I'm going to do the even one. And it's almost the same thing. Not quite, but almost the same thing. And what they do is they say, okay, here's f and here's g, and they have defined, they said p of x is equal to f of x times g of x, and then q of x is equal to f of x over g of x. I'm assuming p is for product rule, q is for quotient rule. And so I'm going to do kind of the same thing. I'm going to do the product rule one, just to make sure we understand how it works, and then I'll give you the quotient rule one to do, right? So the product rule one, well, we're going to do the exact same thing. When I look at this, so the product rule is going to be, so p prime of x is going to be f prime times g plus g prime of x times f of x. That's how the product rule works, isn't it? Right. Now, this is saying, what's p prime of 4? So p prime of 4 is going to equal f prime of 4 times g of 4 plus g prime of 4 times f of 4. I think you can use 4, you can do the same thing. And so it's our job to, how do we get this information from a picture? See, when I gave you a chart, I basically gave you all that information. Okay? I give you this information and you, okay, well, I just sort of plug in. Now you got to do a little more work. Let's talk about it. Okay, so this says f prime of 4. So if this is f, I'm looking at 4. So I want to know f prime of 4. Well, f prime of 4, that's the slope at 4. And so when I look at this picture, it looks like my slope is up 1 over 2. So this has got a slope of 1/2. And then it says g of 4. And so g of 4 is here. This is asking for the value, right? There's a difference. If they ask for f or g, they're looking for what's the height of the dot. If they ask for f prime or g prime, they're looking for the slope at the dot. Well, the height at this dot is 8. And then this is g prime of 4. So what's the slope of g here? What's the slope of our tangent line here? 0, because it's a flat spot. And then f of 4 doesn't really matter, but I guess and f of 4 is sitting at 1. And so my answer is 4. So it's kind of the same idea, okay? Like they give you information, right? They don't give you a function. They don't give you like a nice little polynomial or something that you can physically take the derivative of. You're given information and you have to sort of pick out what information you need to answer the question. So, your turn. I I want you to do b, so if q of x is equal to f of x over g of x, they want to know what is q prime of 7, meaning you're going to take the derivative, and this time you're not interested in the x value of 4, you're interested in the x value of 7. All right, so we use our quotient rule, and now this is talking about what's happening at 7, right? So what's happening at 7? Well, let's see, f prime of 7. So what's the slope? So here we are, this is 7, and this is f, so what's the slope at 7? And if I look at the slope, it looks like it's got a slope of 2. G of 7, what's the actual y value of g? And that looks like it's at 4. Minus, what's the slope of g? Well, the slope of g looks like it's -1. Times the y value, which is 4. All over the value of g squared, so that's going to give us 4 squared. And so if we work it out, I think that's going to give me 8 plus 4 over 16. So 12 over 16 reduces to 3/4. I always kind of like these questions because what it really does is it measures, do you know how to use quotient rule? It doesn't measure, do you remember some little weird thing? There are some things that I have to do to measure that, but this just measures, do you know quotient rule? All right, and the last thing I need to talk about today. And let's say I start with a function, actually, I'll start off with f of x is equal to x squared plus 3x minus 5. What we're going to find out in the very near future is that somehow finding horizontal tangent lines is important. You don't know why horizontal tangent lines are important yet. I'm not asking you to know why yet. I'm just telling you in the very near future, finding out when we have horizontal tangent lines is a big deal. Right? So what do? Well, if I start off with a kind of basic function, a little quadratic, when I take the derivative, so it's going to be 2x plus 3. Right? Easy to take the derivative. I need to talk about what does a derivative mean, right? So a derivative is a formula for the slope of a tangent line. Anytime you take the derivative, the thing I want you to pop in your head is this is a formula for the slope of the tangent line. And here's how formulas work. If I give you an x value, it'll tell you what the slope is. And that's basically what I've done. That's all we've done so far. I give you a tangent, I give you an x value, you tell me what the slope is. But because it's a formula, there's the other way I could do this. One is, and we're going to have to do this, is you're going to have to find out, you're going to have to say, I want my slope to be something. So if I say, what's the slope at x equals 1, that's easy. You just plug 1 in and you get your answer. But the other question that I'm going to ask, and not just me, it's the AP exam, and it's going to happen very frequently, is I want my slope to be something. So for example, if I want a horizontal tangent line, I want my slope to be 0. So if I want my slope to be 0, then I set this equal to 0. And when I set this equal to 0, so I want to get x is equal to -3 over 2. And what I just found was this is where I have a horizontal tangent line. Right? So I was able to find out where do I have a horizontal tangent line. It's basically wherever my derivative is 0. Now, don't take notes on this. This is just, we're going to use calculus to explain a certain formula you've had. Are we okay that the general form for a quadratic is ax squared plus bx plus c? Like where a, b, and c are just numbers. Yeah. And are we okay that the vertex of a parabola, your tangent line's horizontal? It's at a peak or a valley. If you think about, like, here's your parabola, it's going to be horizontal here. Well, if I take the derivative of this, it's going to give me 2ax plus b. And if I want my derivative, if I want the slope to be 0, if I set this equal to 0, and I solve for x, I end up with x is equal to negative b over 2a. Does that look familiar?
The vertex?
Well, think about that's for your vertex. That's the x part of your vertex. That's where you have a flat spot. So, right? Okay, so there's another way to get the negative b over 2a that doesn't use calculus. But since we're in a calculus class, I figured I'd talk about the calculus version of it. You've got, I've given you one question in your homework. No, I think I gave you two. Where I said find the horizontal tangent line, but I didn't give you nice functions. I gave you like some rational function. So let's say I give you f of x is equal to x squared over x squared plus 1. And this is ugly, right? And the graph of this isn't necessarily pleasant. And the question is, find the x values where you have a horizontal tangent line. Where do you have a horizontal tangent line? Well, if you've got a horizontal, if they talk about tangent line, that means you got to take the derivative. So I'm going to take the derivative. So the derivative of the top is 2x times the bottom, which is x squared plus 1, minus derivative of the bottom, which is 2x times the top, which is x squared, all over this bottom squared, and I end up with x squared plus 1 squared. Again, just kind of going through the motions. But here's the part that's moderately interesting. So when you clean this up, what happens? Oh, okay, so I get 2x cubed minus 2x cubed. And it cleans up pretty nicely. I just end up with a negative 2x over x squared plus 1 squared. Here's our derivative. And the question, same question I had the other one. Where do you have a horizontal tangent line? Anytime they ask that, your job is set this thing equal to 0. All right? When you set it equal to 0. Now, I don't know how many times you've had to solve rational function equals 0, but this is my logic. All right? The only way a fraction ever equals 0 is if the top part equals 0. Because the bottom part equals 0, it's undefined. So while this may look really ugly, the only way, when you solve something equals 0, if you have a fraction equals 0, the only way that's ever going to happen is you're going to take the top part and set it equal to 0. Well, if you set the top part equal to 0, that's not so hard. And so the answer to this question is just going to be x equals 0, right? Because that's what we're looking for. All right.